This is a fascinating question at the junior level, 11 and 12-year-old bright mathematicians. It's an Olympiad question. We're asked to find all possible solutions to this word, this digit multiplication. PQ times RQ is equal to the number with digits SSS. So each of these letters represent a digit between 1 and 9. We're being asked not just to find a solution that works, but to prove that we found all possible solutions. This is really critical for questions like, is it not just enough to find 1, 2 solutions, test some others, and then just say, I think I've found them all? Even if you're right, you won't get the credit for doing that. You have to show with mathematical rigor that no other solution will work. So how are we going to do that here? Well, we know that the number is either 111 or 222, 333, and there's going to be 9 different options. Each of these we can see is just a multiple of 111. We consider, okay, 111, that's 3 times 37. So 2 to 2 would be 2 times 3 times 37. And we can continue 3 times 3 times 37 with a prime factorization of each of the cases. Now, since we also know that the last digit of our two-digit factors is the same, we can use this information to eliminate some of the cases quite quickly. So either the 2-digit numbers can be 37, one of the 2-digit numbers has to be 37, or a multiple of 37, which would be 74. 3 times 37, we're now in the 3-digit numbers, so it's not going to work. So only one of these 2 numbers has to be 37 or 74. But if it were 74, then Q is 4, so then 4 squared is 16. S would have to equal 6. So if S was 6, then it would be 74 times something would equal 666. But we can say 74 times 10 is 740. So to be a 2-digit product, it's not going to work, unfortunately. So it'd have to be like times 14, but that's going to be way bigger than 666. So 74 is not going to work. It's going to have to be 37. And then if one of the numbers is 37, then that means Q was 7, in which case 7 squared is 49. So that means SSS would have to be 999. So 999 is equal to 9 times 3 times 37. This is the only other possibility that works. Okay, just to clarify why that is the case, or that even potentially works. One of the 2-digit numbers has to be 37 or 74. 74 we looked at, didn't work. Now we're considering the option that one of the numbers has to be 37, in which case Q is 7. And in this case, we get 27 times 37. 9 times 2 is 27. The units digit is indeed the same in this case. So this works, and we've proven that this is the only case that works. Again, I haven't written enough down for this to be a full, complete proof, but I have explained it. You could fill in the gaps with your explanation to turn this into a formal, rigorous mathematical proof. If you want to remember this strategy and this technique for finding all possible solutions and proving how you're actually going to go about that and save this video, if you know a friend who's going to like this as well, who likes maths, then share it with them.